Let's go ahead and start talking about this chapter. This chapter is basically just parallel lines and planes and the different angles that they create. So we're going to start off with what a parallel line is. Now, prior to geometry, you might just say a parallel line are two lines that don't intersect. But in geometry, now we have to add they are coplanar. And we'll talk about why that's important in just a second. And you'll see that when we get to skew lines. So they need to be coplanar, and they cannot intersect. So what you're picturing are two lines that are going in the exact same directions. One's higher, one's lower, one's left, one's right. So if we look at the picture over here, there's only two parallel lines on here. And that is N and M. They're running the same direction on the plane, and they do not intersect. So parallel lines. When we're talking about that drawing, would be N is parallel to M. Now, see those two lines I just drew there? That's just symbol for parallel. All right, rather than having to write parallel all over and over and over again, those two little arrows are your symbol for parallel. There's one more symbol I want to point out. See these two little arrows that are in here? So when you have a line, you have arrows on both ends. If you have two little arrows inside of here, that is also a symbol for parallel. So those two little arrows inside of here tell you that N and M are in fact parallel. So these are also symbols for parallel. And we'll get into these longer, but say this one had two triangles on it, then this one would need two triangles on it. It's kind of like when you have the tick marks, two tick marks matched up with two tick marks, so that's the way we can show multiple parallel lines. But right now we just have to recognize that if there is an arrow on that line, then those two lines are going to be parallel. Oh, that says symbol. That doesn't say symbol. Ugh. Ugh. There. All right. Symbol for parallel. Skew lines. Skew lines are lines that don't intersect but are not on the same plane. So in this drawing here, if we look at K, K intersects with N. So they cannot be skewed, they cannot be parallel, they're intersecting. K, however, doesn't touch M. If they do not intersect, they're either parallel or skewed. In this case, K is going to be skewed to M because M is on the plane T. That's actually a T. It kind of chopped off there. M is on plane T, and K is not. It cuts through it, but is not on that plane. So that means K and M are skew lines. Planes can also be parallel. Two planes that do not intersect are parallel. And remember, planes go forever. All right, so if I just draw an example of two sheets, two planes, they go on forever. These are parallel. But if I angle one of these are going to intersect eventually, right? When I extend this out, they'd intersect. If they'd ever intersect, ever, knowing that they extend forever, this would be intersecting, this would be parallel. Sometimes the drawings will show them intersecting, sometimes they won't. Sometimes it'll be like this, and you just have to recognize that these will intersect because they go forever in both directions. All right, so be careful with parallel planes. But two planes that do not intersect, so on this case, it would be plane T is parallel. We'll still use that same parallel symbol to U. Notes. I do want us to notes on that. Segments and rays can also be parallel or skewed. Let's use this for parallel. So they can be parallel and skew. Looks like bell. I should have just said parallel. Anyway, be careful with these. Be careful with these. Because let's do a quick example. So let's just do a segment. Let's just use numbers on them. Well, I'll just say these two segments, they're parallel. That's parallel. However, if I had something that looked like this, those would not be parallel. In fact, you would say they are going to intersect. So they would intersect if I extended them. So these are not parallel because they would intersect if they would do that. So those two are not they would intersect if they extended the line, which makes them not parallel. All right, supposed to classify each pair of lines. So we're actually talking about the lines. Even though they give me two segments, you have to pretend they extend forever in both directions. So if I'm looking at AB and EJ, so I'm looking at AB and EJ. AB is this guy. And then we have EJ. So they go forever in both those directions. Can someone tell me, do those intersect? Are they parallel? Are they skewed? Sam, those are parallel. Those are parallel. They're running the exact same directions. They're not intersecting. They're actually on the same plane. We can see they're both on A, B, J, E. So they're on the same plane. They don't intersect, so they must be parallel. So these are parallel. All right, AB and ID. AB, ID. AB is still that same one here. ID is this guy that goes like this. First of all, I'm looking at it, and they don't intersect. So that means it's either going to be skewed or it's going to be parallel. Which one is it, skew or parallel? They do not intersect. Correct? Skew. They're skew. I want you to do the rest of those. So I want you to do C, D, E, F. I want you to do C, D, E, F. Yeah?
Can you share the symbol for parallel?
Yes. Yep.
Is there a symbol?
There's no symbol for skew, unfortunately. Lucky is a short word. The next one is EF and IH. What is EF and IH? EF and RH. Walking around this classroom, walking around the other classroom, this is kind of the most missed one out of all of them. Note that they don't say segment. It doesn't say segment, EF, or IH. It says the full line. So when you look at it, you have to picture it as being the full line that goes like that, and the full line that cuts through HI, which would be that. They would definitely intersect at some point, and so that has to be intersect. Positive? Positive. 100%. All right. Then let's check it because I can't erase that. So we have EF, right? And then we have NM. NM's running back here. This one's running in front. Are they ever going to intersect? No, they're not. So you just have to decide, are they parallel or skew? They aren't running the same direction, so you are right. They are definitely skew. All right, the next one, we have two planes. Are those two planes intersecting, skew? And I'll give you a hint. Planes can never be skew. They can never be skew. They're either intersecting or parallel. They're either definitely parallel. Those are definitely parallel if I colored them in. We have E, J, E. And then we have NIDC, which is this one. If I extended it forever up, and this one forever up, they're probably not going to intersect. Down, no. Down, no. That direction, no. That direction, they'll never intersect. If I extend those in any direction, they will remain parallel. So that's what you're looking for parallel. Kind of like a box, right, that they're across from each other. If there's any angle, they're going to intersect. Like this had kind of that angle that was like that tilting in, so you know they're going to intersect. So you're looking for straight on. All right, any questions on parallel, skew, or intersecting? Okay, let's get to transversals. Let's get to transversal. All a transversal is a line that cuts through two other lines. All right, so it's a line that intersects two or more coplanar lines. Usually it's just two. So in this case, we have line H, we have line K. This line that intersects both of them is called your transversal, which we usually use as a symbol T. So that right there is our transversal. It is just one line that intersects two other lines. You have to know that because we're going to get to times where you have to figure out which one is your transversal. I'll give you a whole bunch of lines, and you have to decide which one is your transversal. Your transversal is always the one I think about that connects your two lines. This T1 connects these two lines together. Yes?
For the next semester, we can have a big packet.
We will not. You actually have all your theorems and stuff on there, because if you go to your theorems, if you look at like theorem 6 and on, they start talking about transversals. So we won't have any more. These are basically all the ones you're going to have for the rest of the semester. We might add a couple to it. That's why you have a whole backside that's blank. So we might add some important ones onto there, but that is the bulk of everything we'll have for this whole semester. Grant?
Could you say H could be transversal? Because if you extended the line and you extend K, it would be an intersecting line K also.
Yes. But that will never happen. You will always know it's a transversal because I will have it drawn. All right, you won't ever have to extend it to see if it would be a transversal. But absolutely you are correct. That would be if I extended those lines. In fact, each of those would be a transversal of the other two. But I wouldn't do that because that gets kind of murky and difficult. All right, so it's a line that intersects two or more coplanar lines. I want to put some important information on here, though. Well, two huge facts. With a transversal, you're going to have something called the exterior and the interior. Your exterior is going to be above and below kind of this like section here. So 1 and 2 are going to be in your exterior. Your interior is going to be anything between the two lines. And you will also have an exterior below. So 7 and 8 would also be exterior. So between the two lines are your interior. Everything else is your exterior. Once again, between is your interior. Away is your exterior because you can turn this. All right, so something that's left and right becomes your interior and exterior. So if I asked you for your exterior angles, your exterior consists of angles 1, 2, 7, and 8. And your interior is comprised of angle 3, 4, 5, and 6. So when I cut two lines with a transversal, I create 8 different angles. 4 are called exterior angles, 4 are called interior angles. That will always happen when you have a transversal. You always have 4 interior and 4 exterior. So yeah.
So like a ray wouldn't be considered a transversal?
A ray can be a transversal.
Oh.
All right, what happens, and you'll see when we draw it, we kind of look at the ray, and we might extend it to be like, okay, this would be the line, is that ray? But I can use a ray as a transversal as long as it it should extend past here to create these two exterior angles.
Then why does it say, well, a line that intersects?
Because you can have a ray and kind of picture it extending as a line. So you can kind of turn that ray into a line. Is that kind of?
Yep.
So we use line kind of loosely sometimes, that it could be a segment that extends as a line. All right, I am missing a slide. But guess what? We can fix it. Technical difficulties, overcome. All right. When we have a transversal, we create those 8 angles. And we already broke those down into interior and exterior. We're going to break it down even further so we can look at specific angles without me saying 2, 3, or 4. So the first thing we're going to have are alternate interior angles. And those say exactly what they are. You're going to look at your interior angles. Those are the ones between your 2 lines. So in this case, that'd be 3, 4, 5, and 6. So I'm looking at the interior. Alternate just tells you they're non-adjacent. So they're on opposite sides of our transversal. So I'm going to circle one. I'm going to circle angle 3. Can someone give me the alternate interior angle to angle 3? Yeah, so angle 3 and angle 6 are alternate interior angles. Can someone give me another pair of alternate interior angles? Yeah. Angle 4 and angle 5. I'm going to put a box around those. Are also alternate interior angles. And those are your only alternate interior angles. Our next one is same side interior angles. So it's still interior. Now we're just same side. Can someone give me, I would 100% agree. So we have 3 and 5. All right, can someone give me the other pair of same side interior? Oh, yay, yeah. 4 and 6. All right, so those basically is, if you know where the interior is, they're not hard because they tell you. Same side or alternate. The slightly harder one that people get confused on is your corresponding angles. It's also a terrible description of it, Sam.
So for these ones, can you abbreviate SS?
Yes, yep, and that's why we actually have those. Yep, because we don't want to write same side, because we might have to do a whole bunch of times and write same side. Yep, we can just go SS angles. Okay, corresponding, I hate the definition, but it is per the book, are 2 angles in corresponding position. I always hate when they use the same word to describe it, relative to the 2 lines. So this is how I kind of describe it or picture it. So I'm looking at angle 1. If I picture just the transversal and line H, that's in the top left position. The corresponding angle is going to be the one on the other line that's also in the top left position, which would be angle 5. So 1's in the top left. So you're looking for one that's in the top left of the bottom one, which is going to be 5. So we have angle 1 and angle 5. Angle 2 and angle 6. Angle 2 and angle 6. Give me a shape. I already used a circle and a square. I need a shape. Triangle. You know, it's the exact same thing the other class did. So we have 3 and 7. All right, I need one more, and I need a shape to put on it. That sounds horrible to do on here, but I'll give it a shot.
I was thinking like a square.
We already have square.
Oh.
There we go.
Yeah.
Nope, I already went with the box.
Nice job.
There we go. All right, so you have angle 4 and 8. Awesome. So those are all your corresponding angles. First 2, they shouldn't be that hard as long as you know where the interior and exterior are. Corresponding, sometimes you can forget about it. What can make these really hard is if I don't tell you what the transversal is. So that's what these problems are. A, B, C, D, R. I don't give you a transversal. So you have to come up with the transversal and the 2 lines that is connected. The easiest way to do that is colored pencil, shade something in heavy, however you want to do it. I'm going to show what angle 7 is. So you're going to find angle 7. And what I'm going to do is I'm going to, let's use purple. I'm actually going to create angle 7. So I'm actually going to draw on top of this and draw angle 7. Then what I'm going to do is I'm going to draw angle 11. And what I'm looking at here is, what are my two lines that are connected by another line? And I'm looking here. Those are my two lines, and they're connected by this line right here. So that means that one that's almost going vertical is your transversal. It is kind of joining these two lines, right? You kind of see that? That I have this line, and this would be connecting it. Mm-hmm. Anytime we draw these, we should be able to see three lines. Two that are running one direction and one cutting into it. You do not. But I highly encourage it, especially on like a big picture or something like that, where you're not sure what the transversal is. All right, then they talked about angle 7 and 11. Knowing that's my transversal, can someone tell me what kind of angles? And it was either Grant or Sam that said, can we just write the shortcut? So I had same side, interior angles. I'm going to let you do B and D. I'm going to do C with you because C is weird. C is kind of a special case. So if I draw C, we're going to do the exact same way. I'm going to draw angle 4. I'm going to draw angle 4. And then I'm going to draw angle 10. There's actually no way to do this one. There's no way to do this one because let's say I extend this line. So picture with me. I extend that line, and now I have a transversal here. 10 and 4 aren't on the same transversal. They have to be on the same transversal. So that wouldn't work. Maybe if I extend it down. Well, that's kind of weird because I would have this whole line, and it might be this is your transversal, but 10 and 4 wouldn't work either. This, in fact, is none. It is none. You should, when you draw these, it should be kind of a clear which one is your transversal and which one's your parallel line. You shouldn't have to kind of guess and draw a whole bunch of lines and hope they connect. What I want you to do is I want you to go ahead and do B and D. Those are ones that have answers. So you're doing B. All right, we're supposed to do angle 14 and 16. So what I'm picturing is color in 14. And then I would shade in 16. Oh, I didn't do 14, that's 13. 14 would be that one. 16 would be this one. Oh, it will not let me draw it on 16. Close enough. And then we look at 16 and 14. This must be our transversal. So what is that? What is 16 and 14 then? What's the answer? So I'm doing angle 3. And angle 6. So this one must be my transversal. And then we'll circle it. We got 3 and we have 6, so they must be alternate interior angles. Yeah?
Why is that one your transversal?
Why is that one my transversal? So what I'm picturing here is, so I'm looking for a line that connects two lines together.
Yeah.
All right? Do you see this line here? There's a line here, and there's a line here. So technically speaking, and anytime we do this, your angles are going to create 3 lines. So you can always extend the angle you created. So if you look at any one that doesn't have double arrows on it, you can actually put double arrows on it. So like there and there. Your transversal is the one that intersects with 2 lines.
Oh, yeah, I see it.
This is the only one that intersects with 2 lines.
Okay.
Yeah. Same thing up here. You can extend these in both directions and arrows. You can do that every single time you're doing this. Just extend these as straight lines.
Okay. Yeah.
And then you can, it's a little clearer. Because right now it kind of looks like 2 rays, right?
Yeah.
But you can always, as soon as you have an arrow on one side, you're always going to be able to, extend it in that direction so you can see what your lines are.
Yeah. Okay.
Which if you would do that on CC, if we're looking at C, if I would do the same thing, extending every single one of these that doesn't have arrows on it, it actually creates the entire box.
Yeah.
So that would be your quick way to go, okay, it's none of them. So you can, when you create your angles, you can go ahead and extend anything that doesn't have double arrows into having double arrows, and it can make your life a little easier. If it's like here, remember, to be interior, it just needs to be between the 2 lines. So our interior is actually, let's see if I can pick this is our interior because that's that area between the 2 lines. So we know 3 and 6 are interior, so either they're same side or alternate. And then you go, well, one's above the transversal, one's below, so it must be alternate interior. So interior is always between the 2 lines. Exterior is always the other stuff. Other questions? Those are great questions. All right, then the rest of the time is yours. I know it does say 22 through 27, and there is a 28th one. I just decided to add that in because it's a good, interesting question.